Hello, welcome back. In this video, we'll discuss three ways that limits fail to exist. It's actually from the end of the last video. And actually very simple. We've already discussed one way that a limit fails to exist, and that's when you have different limits from the left and right of x equals c. So let's say our graph looks like this. And let's say that this is x equals 4, and this is x equals, I don't know, 8, and this is x equals 11. Okay, and let's say that we are asked to compute the limit as x approaches 4 of f of x, or this is a graph of f of x, limit as x approaches 8 of f of x, and the limit as x approaches 11 of f of x. Actually, each of these is a limit that fails to exist, and we'll talk about why. So let's say that value is 2 and that value is 1. Let's say that value is 3. This is, of course, not to scale. Okay, so if I'm taking the limit as x approaches 4 of f of x, well, the way I determine that limit is I look at the graph itself and I think about what happens to the y values on the graph as x approaches 4. Remember, this is the limit as x approaches 4 of f of x is equal to a particular value if as x gets arbitrarily close to 4, y equals f of x gets arbitrarily close to that particular value. So we just have to figure out what y gets arbitrarily close to as x gets close to 4. So we let x approach 4 from the left-hand side, and we see what the y's approach. In this case, the y's approach 2. So we could write the limit as x approaches 4 from the left of f of x equals 2. And then similarly, we could let x approach 4 from the right. And we'd use this notation for that. Take the limit as x approaches 4, and we're doing that from the right, so we're going to use a little plus sign there. We say as x approaches 4 from the right, what do the y values approach? The y values approach 1. And those two limits are different from each other. If the limits are different from each other, then that limit fails to exist. So in general, we would have this limit from the left is 2, this limit from the right is 4, and the limit as x approaches 4 in general is just a limit that does not exist. So we'd write DNE, does not exist. Now, it's also possible that our function can, or our limit can fail to exist if the function oscillates rapidly between two values as x approaches that particular number. And there's a particular example that's really interesting. Well, we're going to look at that in a different video. We'll have y equals sine of 1 over x. When we look at the limit as x approaches 0 of sine of 1 over x, it's going to have very similar behavior in the graph to this graph that I've drawn here. But here we're saying that sort of the interesting things happen and just sort of gets denser and denser, actually, as x approaches 8. So we're going to say the limit as x approaches 8 of f of x does not exist because the function is oscillating between two values, whatever those values are, as x approaches 8. And we'll discuss that in more detail when we look at this function and when we discuss the epsilon delta definition of a limit. And then over here, when we take the limit as x approaches 11 of f of x, again, we can look at the limit from the left and from the right. And we say, well, what is the y value here? As x approaches 11 from the left, the y value is approaching whatever that number is. And I'm just going to guesstimate. Let's just say that that's 5. If that's a 5, then we have the limit as x approaches 11 from the left of f of x equals 5. And then we might look at the limit as x approaches 11 from the right as well, that little plus sign means from the right. We say as x approaches 11 from the right, it looks like those y values are going to infinity. That is, they're growing, increasing, and increasing the farther we go to the right. And so we'd write equals infinity. And since those two values are different, they're not the same as each other. The limit as x approaches 11 in general of the function does not exist. Now, even if this limit happened to be the same on the left and right-hand side, so let's just look at a different function like this. Let's say that's x equals 3, and x is approaching, or as x approaches 3 from the left and from the right, the y values go to infinity. So the y's just keep increasing on that side, and they just keep increasing on that side. In this case, we would write the limit as x approaches 3 of f of x equals infinity, meaning it goes to infinity on the left of 3 and it goes to infinity on the right of 3. But actually, that limit doesn't exist. It doesn't exist in a particular way. And we say that that function has unbounded behavior. But since it doesn't exist in a particular way, and it's a very predictable and important way that the function's actually growing without bound, it's going to infinity, we write that this limit as x approaches 3 of f of x equals infinity. And just notation, that means that this is actually what's happening. We can't think of infinity as your L value. We don't want to think of it that way. But there's a slightly different formal definition or rigorous definition of the limit in this case. But we won't get into that here. We'll talk about that when we talk about epsilon delta definitions in a future section. So that is one way that a limit can fail to exist. And those are our three ways. So we had a limit that fails to exist because we have different limits from the left and from the right. That's one of them. Then we have a limit that fails to exist because the function is oscillating rapidly between two values. And that's another example. And then here we have an infinite limit, or a limit that fails to exist because the function has unbounded behavior. This has unbounded behavior, but we can write an answer for that limit, even though that answer is not a finite number. And then over here, the limit doesn't exist because it has unbounded behavior, but it also has a different behavior from the left than it does from the right. So the limit doesn't exist for both reasons there. So those are our three ways. I think I did that in a slightly different order, but you get the idea.